So in the first video I showed you guys what my plan was for cutting out this part right here on a 3-axis mill. We were going to go from operation 1 to 2 to 3. You would start with this solid chunk, machine it into this part, flip it over, basically do the same thing on the other side, and then put it up on its side, and then you're going to drill your holes and finish the rest of the features. Now this is a completely viable way to machine this part, but one of the downsides is that you have to process your bar stock, you have to saw cut every single one of these little pieces. The operator has to manually unscrew and screw in all these parts. You know, you're losing accuracy whenever you transfer from operation 1 to 2 to 3. And it's a completely sound way to do it, but in today's world we have lathes that have live tooling, indexable turrets, bar feeders, parts catchers, and those machines are becoming more and more common. So in my opinion, that's a much better fit for this type of part. So in the end, we'll break down the cost differences, the time savings between both. But for now, I just want to give you an example of the CAD programming of this, which we already showed. And now I'm going to give you an example of the CAM programming, the CAM programming of the turning. So let's go ahead and isolate this part right here, which is where we're going to be doing the CAM programming for the lathe. So we'll just come up here, isolate the final part, and then we'll go back to our manufacturer workspace. Okay, so now we're in the manufacturer workspace. You can see in my setups down here, op 1, 2, and 3 were for milling. We're going to turn those off because we're just turning. So here you can see all of these operations in operation 1, 2, and 3. These all got put into turning. I reposted them and I redid them, but basically all the features that were being cut on operation 1, 2, and 3 are going to be able to cut in one go off of a piece of bar stock. So this is a 3/4 inch piece of bar stock, and we'll just go through the operations and show you how this can be done on a more advanced but still perfectly reasonable lathe. So let's go ahead and simulate, and we'll just go through each one of these. So let's get ourselves set up here. The orientation is a little hard to grasp. There we go. And in case you're wondering, I didn't know this at first, but these tool holders right here for CNC lathes, they're upside down, so that as you're cutting the chips are fighting gravity and they're falling down away from the insert instead of falling onto the insert. It increases tool life. It's pretty common. It looks a little backwards and weird, but it's actually what they do in the real world. So first we're going to start off by just facing the front of this part. Just going to come in and face it. And then we're going to go through and do a profile of the shape. We're just getting rid of that extra meat and getting down to our squares, the square of the part. So now that we've done that, we're going to come in with an end mill. So this is part of live tooling. You can put end mills on today's lathes if you have live tooling. So we're going to come through and do a couple passes and get this down to a square. So it does a couple passes, and then it does a final finish pass to get rid of 10,000ths. And then after that, we're going to come through and do our slitting saw right here while the part is still relatively rigid. We don't want to save that for last, otherwise the part might not be rigid enough. So you're going to see that this is going to pull up and push back down. If I was actually cutting this part out, I would clean up that tool path because that's wasted motion. But since we're not actually doing a full production run of this part, we don't need to spend hours and hours trying to perfect the tool paths. So then now, while the part is also still rigid, it's going to go down and plunk all these holes in it. Hole there, hole there. Now we're going to go back and we're going to tap. 4-4D tap. I'm going to take care of those. Now we're going to come back with our end mill. Now that our part is still rigid and we got all the features into the part while it was still rigid, now we can go back and remove the rest of the material. So just like the previous one, this one's going to do a couple of passes, and then it's going to leave 10 thou for a finishing pass. You can still see there's a little bit of meat left. Now it's green, it's going to come through and remove all that. Great. So now you can see the part's actually almost done. So now we're going to come in with our slitting tool and we're going to turn this part right off. So there you can see, it's just going to turn it, boom, and then we're done. So now at this point, this part would fall off into a parts catcher or fall off into the conveyor belt of the bottom of the machine. And then the idea is that this machine would have an automated bar feeder. So after this part came out, this bar would get pushed up another couple inches, and this whole process would repeat over. So basically you take your part length minus the facing and the grooving, and you divide that by the total length of the bar that you have in the machine. And these bar feeders can have multiple bars. So if you had 5 bars that were 10 feet long, you could potentially run this part over a whole weekend and come in on Monday and have plenty of good parts. The caveat is that you would need to have your process dialed down to where there's no broken tooling and there's no surprises. Your tool management would have to be perfect. But that's definitely something that's accomplishable. You could have sister tools so that when one wears out, you could trade another one in. But without even looking into the numbers of what it would cost to set up that mill and set up a lathe like this, you can kind of already get a gut feel for how much faster this would be and how much cheaper this would be. Of course, it's good to break everything down, but eventually you build a feel and you know that you can see a part and know if it's a good part for a mill or if it's a good part for a lathe. And in my opinion, this is a much better part for a lathe because it can be automated so much easier. But that's just my take on this. So thank you for watching.